Hey everybody, welcome to the fourth lesson of Unit 2. Today we're going to talk about justifying all the steps I've taught you in the last few lessons. So there are good reasons for why we can do the math we can do, and we've got to learn those vocabulary words and know at what steps we're using what justification. So today's aim is I can justify the steps I take to solve an equation by using mathematical properties. We've talked about a few of these in Unit 1. We talked about the associative property and the commutative property, grouping property, and the order doesn't matter property. Well, now we're going to talk about two more properties. So let's read. Now that we've reviewed how to solve linear equations involving variables on both sides, it's time to take it to another level. The Common Core asks us not only to know how, but also the why. Generally, we justify the steps we take in solving linear equations using the commutative, associative, and distributive properties of real numbers, along with the following two properties of equality. Okay, equality has that word equal in it. That will be a big hint here. So the first one is the additive property of equality. I also want to note that this includes subtraction as well. So it's the additive property of equality, which says that if two things are equal, if A equals B, then A plus C equals B plus C, meaning you can add or subtract the same quantity from both sides. We've been doing this all of Unit 2. If we subtract 3 from one side, we subtract 3 from the other side. Well, this is called the additive property. It has a name. The other property is the multiplicative property, and we can also include division here as well. So that says that if two things are the same, then if we multiply or divide by the same quantity on both sides, it stays equal. That's like saying if I multiply one side by 3, I have to multiply the other side by 3. So we have two new properties to work with. So let's take a look at exercise 1. And in exercise 1, it says consider the equation 2x plus 9 equals 21. The steps in solving the equation are shown below. Justify each step. Justify means give the name of the property that is what that each step is doing. So step 1. It's that this equation starts off with 2x plus 9 equals 21. Now you have to look for the difference. What happened from the original to the new one? Well, both sides were subtracting 9. That's the additive property that we just talked about. Even though it's subtraction, we call it additive. I know that is confusing. Okay, it's the additive property. Okay? The second step, what's different now? Well, now there is a 1/2 being multiplied on both sides, and that would be the multiplicative property. You have flashcards, or you will have flashcards for these two properties when you get them in class, and you need to memorize them for exams. The trickiest part, I think, is noticing what changes from step 1 to step 2. So what's the difference between step 1 and step 2? What's happening there, and then once you notice what's happening, then you can give it a name. Okay? Let's take a look at exercise 2. Now here's a really long problem. Consider the equation 3 times x plus 2 minus 2 times x plus 7 equals 4x plus 7. As in the last problem, each step of the solution is shown. Justify each with a property of equality or property of real numbers. So, you should have 5 properties in your mind. The 2 we just learned, the additive property of equality, the multiplicative property of equality, and we have 3 others. We have the associative property, which is like your grouping property, basically. It talks about grouping. Your commutative property, and that's basically saying that order doesn't matter. And you have your distributive property, right? Which is like saying, you know, you can distribute things. Distributive also includes factoring. So when we do backwards distribution, that's also considered a distributive property. So let's take a look here. Step 1, 3x plus 6 minus 2x minus 14. So what's happening from the original to this one? Well, it looks like to me they did what? They distributed. So they did the 3 to the 2 in the x. They did the negative 2. Hold on, let me redo that. They did the 3 to the x, the 3 to the 2, and then they did the negative 2 to the x to the 7. So this would be the distributive property. The next step, looks like they rearranged the terms. So see how they switched the negative 2x and the 6? Rearranging is that commutative property where order doesn't matter. Step 3, it looks like they're combining like terms here, but it's kind of like backwards distribution. They're combining the 3x and the negative 2x, so that's kind of an interesting form of distributive property. I would also say if you put combining like terms here, I think that would be okay as well, because that's what they're doing. They're combining like terms. That's what this is. They're saying, look, 3 minus 2 gives me a 1, and that's where they get the invisible 1 in front of this x here, right? They're also combining the 6 and the negative 14 to get that negative 8, so they're combining like terms. The next step, what does it look like they're doing? It looks like they are, they're subtracting a 4x from both sides, and they're adding an 8 from both sides. So minus 4x and a plus 8, so this is the additive property. I know it looks different than how we do equations. These equations are done left to right, and the equations we do in class are top to bottom. So finding what's happening in these steps is the trickiest part. The next step, it looks like they are rearranging the terms again. They've put the 4x's together and they put the 8's together. So this is the ordering property, which is the commutative property. And then step 6, they're combining like terms, the x's and the numbers, so this is a form of distributive. And I'm sorry for my handwriting on here, it's kind of hard on my tablet. Combining like terms. And then finally, they're dividing both sides by negative 3 here, and even though it's division, we just learned that it's the multiplicative property of equality. So again, the hardest part is seeing what's different between each step. Okay? Remember, you have to memorize these properties, so that's why I give you vocab cards on a ring, so you can quiz yourself and memorize all of these properties. Strange things can sometimes happen when you solve an equation. Even if every step is justified, results can turn out confusing, and exercise 3 is going to show us how. So let's take a look at exercise 3. It's asking us to justify again each step. So they give you the first one. Look, the first step was they took this equation and they distributed. So they went from here to here, they distributed. The second step was, look, they're rearranging the terms again, I believe. Oh, no, I'm wrong. They are subtracting 8 on both sides. So that is the additive property, even though it's subtraction. It's the additive property of equality. The next step is that they're combining like terms here. So again, it's a form of distributive, but we can also say combining like terms. Step 4, they tell you it's the additive property because they're getting that negative 2x on both sides. And then finally, this last step is they're reordering the variables, so that's the commutative property. And even though every step is justified, look what ends up happening at the very bottom. Look at that. Is negative 11 actually equal to 0? No. So let's take a look at B. The final line of this set of manipulations is a very strange statement. It says that negative 11 equals 0. Is this a true statement? No. Negative 11 does not equal 0. What's the second question? Could any value of x make a true statement? The answer to this is no. What happens is that if you can justify every step of your equation and you get something where at the very end the two numbers are not the same, that means that that equation is a false equation. So no values will make this true. No matter what we put in, nothing will work. And that's kind of what C. What do you think this tells you about the solutions to this equation? There are no solutions. Okay? Now this happens a lot sometimes with teachers. They'll write an equation on the board, they'll make it up for practice, and it turns out that there's no actual solution to it. It happens all the time. Just because you put a combination of numbers and letters together on one side of the equation doesn't mean it's going to equal whatever you put on the other side of the equation. So if this ever happens, I'm going to circle it again, where you are checking your work and you get two things that don't equal each other, that means that the equation has no solutions. Okay? And let's take a look at another situation that's kind of strange. So we just looked at an equation that has no solutions, but let's take a look at this new equation. So exercise 4, consider the equation 7x plus 2 times x plus 5 equals 9x plus 10. So letter A says, show that x minus 5 and x equals 2 are both solutions. How do we show that? Well, how do we show that they're both solutions? Well, we plug it in. Plug them in. So I'm going to do x equals negative 5 first. Okay, x equals negative 5 first, so I'm going to take x equals negative 5 and plug it in. So I'll get 7 times negative 5, I'm plugging into this original, plus 2 times negative 5 plus 5 equals 9 times negative 5 plus 10. Now I'll simplify. 7 times negative 5 is negative 35, plus 2 times negative 5 plus 5 is 0, equals 9 times negative 5 is negative 45, plus 10. On the left side, I see that 2 times 0 is 0, so I can cross that out, and I'm left with just negative 35. And negative 45 plus 10 is negative 35, so x equals negative 5 is a solution. Now let's try x equals negative 2. I'm going to do that in green. So 7 times 2 plus 2 times 2 plus 5 equals 9 times 2 plus 10. So I'm just plugging in 2, so wherever I see an x, I'm putting a 2. Now let's simplify. 7 times 2 is 14, plus 2 times 2 plus 5 is 7. 9 times 2 is 18 plus 10. This becomes 14 plus 14 equals 28, and 28 does equal 28. So both x equals 2 and x equals negative 5 is a solution. Letter B says, solve this equation by manipulating each side of the equation as we did above. What does its final strange result tell you? So this is weird that first of all there's two solutions to an equation. So why don't we just take the original, 7x plus 2 times x plus 5 equals 9x plus 10, and let's solve it. So I'm going to carry down the 7x and distribute the 2. So I get plus 2x plus 10 equals 9x plus 10. I'm going to combine like terms. 7x and 2x become 9x. And I'm going to stop right here, and I want you to notice something. Notice that both sides are what? Both sides have exactly the same expression. 9x plus 10 equals 9x plus 10. Now, if I keep going, and I want to just try and solve for x, something weird's going to happen. I'm going to subtract 9x on both sides. 9x minus 9x is 0, but 9x minus 9x over here is also 0. So now I got 10 equals 10, which is a true statement, and suddenly I don't have an answer for x. So what does this mean? This means that this equation has infinite solutions. Meaning, any number will work. So sometimes equations have no solutions. So we have three options. Sometimes there are no solutions. Sometimes there are infinite solutions. And then what we've been working with all unit is that there might just be that one solution. So those are the three options for how an equation can turn out. Right? So let's test this equation by picking a random integer, or really any number, and showing that it's a solution. So let's pick a number, and you could pick one on your own and try it if you want to. But I always like picking an easy number, and the easiest number I can think of is 1. So I'm going to pick the number 1, and I'm going to say, let's let x equals 1, and I'm going to try this one. So 7 times 1 plus 2 times 1 plus 5 equals 9 times 1 plus 10. And I'm going to start to simplify. 7 times 1 is 7, plus 2 times 1 plus 5 is 6, equals 9 times 1 is 9, plus 10. 7 plus 2 times 6, that's 12. 9 plus 10 is 19, and look at that, it worked too. So this equation has infinite solutions. So the objective today was to understand the idea about equations having infinite solutions, no solutions, or just one solution. And if we go back to the beginning of this lesson, remembering about these rules of justifying your steps in an equation. So go ahead and you can start your fluency if you like, or wait till you get to class, and I'll be happy to help when I see you next.